GNU toolchain versus Clang LLVM toolchain. Realistically, both of them are great. They support debugging, they support latest standards. Tooling-wise, however, Clang provides better tools like static analysis, like code tidy, and also it generally emits better diagnostics and error messages, just the wording itself. So for these purposes, I kind of prefer Clang, and its modular architecture technically allows one to inject like some custom built tools into the chain, which I'm not doing, but it's nice to have an option, I suppose. GNU and Clang, they support ARM v5 code perfectly fine, which is what our ARM 926EJ-S CPU on the FX3 dev kit is. So it's a matter of preference, more or less. However, Clang does have one thing is that I kind of sort of like. It supports so-called thin link time optimization, which is using far less memory and still allows cross-translation unit code optimization, which is nice. It allows function inlining and all that. And because of that, we are gonna see today what does it take to move from GNU GCC G++ toolchain to Clang LLVM. Let us do this. First of all, let's go to our Visual Studio installer and add Clang, which we have not done yet. Our installation lacks Clang. So we go to individual components, we type in Clang into the tool, into the search box, and we don't need MS Build support for LLVM. I don't currently have any plans for using this in like Microsoft MS Build style projects, maybe later. So for now, just do the Clang. Let's say modify. That's gonna be quite a few gigabytes. So I'm gonna speed up the video here as to not to bore you with the details. And of course, we also want to update while at it, because why not? Now that we have LLVM installed, let's find where does it live. Let's enable this navigation pane. Let's go to our C drive. It's gonna be somewhere where Microsoft Visual Studio is, obviously. So let's go here and just search for Clang, I suppose, because why not? Aha, we get some Clang folder. Let's see. Right click, open folder location, we get into, this is what we're looking for. It's inside community VC tools LLVM. That is strikingly close to where the Linux used to be. Aha, good. So now we can go here and figure out how do we update our makefile to switch from G++ to LLVM. First things first, of course, we're gonna set Clang root environment. We need to set it properly to point to this location. Here's the makefile. Here we'll start with Clang root, and let's use the question mark equal to allow us to provide where Clang root lives in a system. It's not strictly speaking necessary, but this is gonna be VC and then tools and then LLVM, and now we're gonna replace a bunch of things. So let's use multi-line editing. So the way I put the cursor on 3 lines, let me escape from here. So if I hit Alt, Shift, and then holding Alt and Shift and go with the down arrow, I start putting multiple cursors across the lines. And now we can control right, and you see it jumps through each word separately. So we can select ARM GCC install path in all of this and say Clang root instead, but more interestingly, we can control shift right arrow, right arrow, right arrow, and it will select as much as we need. You see, pretty. So this was Clang for CC and CXS and linker Clang++. Next we go and you know what, let's just see what happens if we just build it as is. Would it work? Probably not. we got errors, and the first one would be unknown argument mthumb-interwork. That is correct. This one is not supported by Clang, so we're gonna remove this one and replace it with, where is it needed? It was needed, I believe, in the assembly file. So let's build it and see if we get any special treatment here. We get errors. It's really unhappy. Well, it's unhappy because this mCPU ARM unused argument ARM, how can it be unused? Because it does not know which architecture we are building for, right? So for the Clang, we need to specify the target triplet, which in our case is ARM non-EABI. We could have said ARM 9, but I think that works just fine. Let's build this assembly file again, and it is unhappy about expected absolute expression. We are looking at the GNU extension to assembly syntax. This inter equals true is actually coming from the GNU toolchain when we specify inter some whatever that other thing it was here before. In our case now, what we can do is just do the preprocessor. As it turns out, Clang runs a regular C preprocessor on the assembly file, but we do need to take care of this inter equals true part, for which we go here into assembly. This is assembly specific, so assembly over here, we'll just define the symbol. That's as simple as that. So inter equals true, which should be good enough to build the S file. Build. It is happy. Let's see what else is wrong in our migration. We get stdlib. Now, well, first things first, FABI version. ABI version is not supported by Clang. That is true. And instead, we can just remove it. It is outdated there. It's not needed. So just get rid of it. Build again. What were the other errors? The other errors were stdlib. For this, we can just tell the compiler where the sysroot is, because we need to use the sysroot from the ARM GCC, which would be sysroot equals, well, we'll of course double quote things because we may be in directories with spaces, and on Windows we don't want to get into problems. So it was ARM GCC install path, and after that it was ARM non-EABI, which is where the sysroot is. We'll probably add a slash in the end. And now let's build. What do we get? A much happier compiler which says unused argument no start files. True, that is not Clang. Remove that. And this one is also true, that does not exist in Clang. No warning here. Let's build one more time. We are missing some of the standard libraries which come from -lc and -lgcc, and potentially also the C++ would be from -lstdc++. So these should make it happier, much happier. The unwinding, right, for C++ we do need to say that we are not using no stdlibs support, which means we don't need this one over here. And as far as the build goes, the script file, it was not properly, there is a minor issue here which did not bother us before. Let me do multi-line editing again. So Shift Alt down, then I'll hit the end button key, and then Control left, and over here we need 4 commas between origin and length. Let's build again, this time with feelings. It produced code, which is great. Ooh, wait, is that? Oh, this is bad. It's supposed to be common flags over here, because we are overwriting it right here with the compile flags. Oops, my bad in the previous episode, I suppose. Yeah, this is supposed to be common flags, not compile flags, because then it's going to be used over here. What do we have now is a build that we should test if it's working. So let me turn the device on. Let me open up our putty. Come here. I'll just make it smaller. let me open up our testing camera app because we want to see if it's working. And on top of that, let's see our control center, Cypress control center, which would show us, okay, so we are running the streamer example device, which, let me reset the device, it should go into bootloader mode. There we go, bootloader mode, right click, deploy to RAM. Do we see anything? Firmware downloading succeeded, and we can't see anything at all. I did spend some time debugging, so let me reset the device back, and it turned out that there was a minor difference that was creating a serious change, and the difference was the size of enums. In here we need to specify short enums flag because that is required. So let me go now from the streamer example to bootloader, and now hopefully with that one change, short enums, we should be good to go. I see video, yay! This is it, that's all it takes. Let's just take a quick look at the diff. It was not that painful, except for this short enum thing that took me a while to find out offline. So that was a change to go from GNU extended non-standard syntax to a more standard one. This was also to correct for commas, because that's the way to do it appropriately. And in here what we did, we specified the Clang root is coming here, and then we replaced our toolchain with Clang and Clang++. We also had to add these guys. In here we did specify the target triplet, so that Clang knows actually what we are compiling for. And mthumb-interwork is not supported flagged by Clang, which is why we went to specify this define over here that has been passed into assembly so that our preprocessor works properly. On top of that, we fixed this bug over here, which is now appropriately set the common flags, which are then being used in the compile flags. And we did specify the sysroot so that Clang knows where to get the system header files, the libraries, and all the shebang from. Outside of that, no stdlib, and in here we said no to no start files because it's not supported in Clang, and this no wchar size warning was also not there, so we got rid of that, which is all it took. Now let's commit. This was season 1 episode C, I believe, G++ to Clang LLVM. Let's just be it's not G++, it's GNU. So GNU to Clang LLVM. Let's commit, push to origin, and next time come join me. I think I'm gonna try out the Copilot and we will wipe code a little bit and see how that goes. So thank you for watching, and see you hopefully soon in the next video.